Sorry I'm late. I've recently started training for my first 10K race, but it's been kind of tough. Not necessarily the running part though, that's fun. I'm trying to stay hydrated, and lugging all these sports drinks up and down the steps of my apartment, that's hard. I think I'm gonna switch to powder. The directions indicate that all I have to do is add 1 scoop to 250 milliliter glass of water. Voila! In chemistry, we refer to this as making a solution. The water is called the solvent, and the powder is called the solute. But this 250 milliliter glass isn't going to do it. I'm pretty thirsty, so I think I'll make a 500 milliliter glass. How much powder do you think I should add? If you said twice as much, your intuition was correct. Since I have twice as much water, I need to add twice as much powder. The ratio between the amount of powder and the amount of solution is all that matters. This concept is closely related to what we call the concentration of the solution. For sports drinks, we usually don't need to be extremely precise about the concentration. But in certain cases, such as preparing an IV solution for a patient or testing the amount of lead or arsenic in drinking water, it's crucial that we're precise in how we make and report concentrations of solutions. If we're going to be precise about making these solutions, we're going to need to make sure that the solute is fully dissolved, making the solution homogeneous. Ever notice that your bottle of face wash says 2% salicylic acid? One way to express the concentration is as a percentage. There's weight percent, which is grams per gram, or volume percent, milliliters per milliliter. We can also have a weight by volume percent, grams per milliliter, which is how salicylic acid's represented in your face wash. And let's suppose you start with a 500-gram glass of water, the solvent, and 20 grams of powder, the solute. When we combine these together into a solution, just like that, it gives us a total of 520 grams of solution. We can calculate the percentage of powder in the solution. We have 20 grams of powder per 520 grams of solution, and then we multiply that by 100%. This gives us 3.85% by mass of the powder, or 3.85 grams of powder per 100 grams of solution. The remaining 96.15% is water. Expressing concentration as a percent by mass can be useful. Let's say I'm only going to drink some of the solution, perhaps 75 grams, and I want to know how much powder I'm consuming. Percent by mass is great for this. In our previous calculations, we found that 100 grams of solution contained 3.85 grams of powder. Therefore, 75 grams of solution will contain 2.89 grams of powder. How did I get this? Well, I multiplied the 75 grams by the percent by mass ratio. 75 grams times 3.85 grams of powder per 100 grams of solution equals 2.89 grams. But how often do you weigh a liquid? Chemists often work in terms of volume. We measure out 100 milliliters of solution. For that, it would be useful to have units of grams per milliliter of solution, or percent by volume. So, if I have a solution with 20 grams of powder per 1,000 milliliters of solution, and I drink 100 milliliters of that solution, I would consume 2 grams of powder. Okay, now that we've done the math, let's try making that solution using this 1,000 milliliter or 1 liter volumetric flask. As you can see, I've filled the flask to this line, which tells me I have exactly 1 liter of water. Now I'll add my solute. Pour it in and mix until it's dissolved. But wait! The total volume of the solution increased when I added the powder. In order for me to end up with a total volume of exactly 1 liter of solution, I have to make sure that the 20 grams of powder is fully dissolved in the water without going over the 1 liter. How can we do that? Well, this time I've added my powder in first. Now I'll add a little bit of water so that I can start the mixing process. This may take a minute. Add a little more water. My solute is now fully dissolved, and I'm just trying to get the solution up to 1 liter. But I'm not going to go all the way up to the line until I start fine adjusting. You got to be careful not to come all the way up until I kick in the fine adjustment. Getting the meniscus just to the line. And now for my triple inversion. This way, I have exactly 1 liter of solution with 20 grams of powder in it. Grams per liter is a fine unit if you want to stick to the macroscopic scale. But we're chemists, and we know that the power comes from the atomic scale of atoms and molecules. So chemists often report concentration in a unit related to the number of particles in a liter of solution. Remember that because atoms are so small, when we want to think in terms of a number of particles, we use moles of particles as our counting unit. This gives us the number of moles per liter, which is a unit we call molarity. We symbolize molarity with a capital M. Sucrose is an important component of my sports drink. So let's focus on that. If I make a liter of solution that contains 20 grams of sucrose, what's my molarity? All I have to do is use the molar mass of sucrose to convert from grams to moles. So I know I have 20 grams of sucrose in 1 liter. Multiplying by 1 mole per 342 grams, which is the molar mass of sucrose, resulting in 0.058 molar, or moles per liter. All this talk about concentration is making it hard for me to concentrate. I think I'll go for a run, clear my head.